Hello everybody and welcome to this edition of our GMAT Ninja Quant video series. It's so great to have you with us. In this video, we're going to cover those hard data sufficiency questions where you kind of got to combine some algebra, you got to combine some logic, and then hopefully you're able to work your way to an answer choice. We're going to be covering those questions where sometimes you look at it and say, I don't know what to do at all. I'm just going to pick numbers and hopefully I'm able to get myself to an answer choice. Those are the types of questions that we're going to cover. They tend to show up more in inequality, in the form of inequalities or absolute value. So we've entitled this video Beyond Algebra, Inequalities, Absolute Value, and more. But the questions that we're going after in this video are primarily those hard ones that you see on data sufficiency, where it's like, I don't really know what to do here. Let me just guess numbers. Let me test cases. Let me see if I can figure something out. Those are the questions that we're going after in this video. And again, this video is going to be more challenging. It's going to be on the harder side. The first few questions, we're going to get some basic skills down. But the second half of this video, or really the middle and the end of this video, are going to cover some really challenging questions. And so if you're looking to score in the 45 to 48 range on quant and you get to that second half, you just get obliterated. Don't worry too much. Those are intentionally very hard, intentionally very challenging. And you've got to be scoring at a really high level to be able to get those questions right. This video is for you probably if you find yourself testing cases or guessing numbers, if you feel like you know everything but you still struggle, if you oftentimes are having a hard time deciding whether to use logic or algebra, you don't know which tool is going to be most effective. We'll cover a lot about that in this video. And then also if you struggle with or don't have a consistent approach to those hard data sufficiency questions, you just see it and it's like, I don't know what to do here. Let me just guess numbers. In this video, we'll cover hard data sufficiency questions. We'll also talk about when to pick numbers. Spoiler alert, never. So that's never not really helpful very often. And we'll cover, not only will we cover that in this video, but we'll also cover, okay, I'm not supposed to pick numbers. What should I do instead? We'll cover that in this video. We'll get into inequalities and absolute value as well. So hopefully this video will serve to help you in that sense. In this video, we're going to talk a lot about pushing the question. We're going to talk about using those logical skills, using algebra, and we'll cover all of that. But I want to go ahead and let's get into a question here to start. What I'm going to do is I'm going to go ahead and I'm going to put this one up on the screen. I'll give you some time to work through it, and then after you've had some time to work through it, we'll come back and we'll talk about it together. Awesome. Hopefully you've had a second to work through this one, and we'll go ahead and take a look at it on the board. If you haven't had a second to work through it, go ahead and pause the video right here. But the question asks, what is the value of x? Statement 1 tells me that 5x cubed is equal to 125x. Statement 2 tells me that x squared is not equal to 25. So let's go ahead and talk about statement 1 here first. Statement 1 tells me that 5x cubed is equal to 125x. And if you're like most students, your first reaction here is, okay, let me first eliminate my 5's, right? I can divide everything by 5, say that x cubed is equal to 25x. And then from here you say, well, okay, great, I've got an x on both sides. Let me go ahead, I'm going to divide everything by x, and I'm going to get to x squared is equal to 25. Okay, x is equal to plus or minus 5. Great. And then from here, okay, that's not sufficient, so I can eliminate a and d. Then you look at statement 2, and you say x squared does not equal 25. Obviously, that's not sufficient. When I look at them together, oh, wait, statement 1 tells me that x is equal to plus or minus 5. Statement 2 essentially tells me x squared does not equal 25, which means that, of course, that x is not equal to plus or minus 5. So things start to look a little bit confusing. And here's why. Obviously, if you have been doing the GMAT for a while, you know that the two statements can't contradict each other. And if I were to solve things like this, then the two statements would contradict each other. So the problem here is what I did in this second step when I divided by x. I'm fine to eliminate the 5 on both sides, but I can't actually divide by x here. And the reason that I can't divide by x is because I don't know whether or not x could be equal to 0. As long as it's possible that a variable could be equal to 0, I can't divide by it, because you can't divide by 0. And so what's going to happen is I'm going to end up eliminating a possible solution if I divide by a variable that could potentially be equal to 0. So instead, because and obviously the GMAT has several ways of telling you that a variable couldn't be equal to 0. You know, if it's positive, if it's negative, xy does not equal 0, right? The GMAT has plenty of ways of telling you whether a variable could be equal to 0. But what I can do here instead is this, is that I'm not at a total loss. Instead, what I can do is I can pull everything to one side. So I can say x cubed minus 25x, right? Because I can subtract by 0, is equal to 0. And then what I can do is I can start to factor. Okay, x, pull out an x, and I've got x squared minus 25. When I see x squared minus 25, I know that's a difference of 2 squares, x plus 5 times x minus 5 times x, and that is all equal to 0. When I get to this stage, okay, now I have some possible solutions for x. X could be equal to 0, x could be equal to negative 5, and x could be equal to 5. So I have 3 possible solutions for x. That's not sufficient, right? I need to be able to solve to just one possible solution for x, so I can eliminate a and d. Next, I'm looking at statement 2 alone. Statement 2 alone by itself, x squared is not equal to 25. That's not very helpful. It just tells me x can't be equal to plus or minus 5. So I can go ahead and eliminate b. Now I look at both statements together. With both statements together, from statement 1, I know that x is equal to 0, negative 5, or 5. From statement 2, I know that x squared is not equal to 25, so that means I can eliminate negative 5, and I can eliminate 5, and that tells me that x is going to be equal to 0. So important takeaway here, and this is going to be foundational as we continue to move forward onto even more challenging problems in the latter half of this video. But important thing to keep in mind, you can't divide by 0. So what do you do instead? Well, because you can't divide by 0, and instead of trying to divide, what you're going to do is you're going to pull everything to one side and factor. With that in mind, I want to go ahead and take a look at another question together. Again, I'll put it up here on the screen and take a minute to work through it, and then we'll talk through it together. Awesome. Hopefully you've had a second to work through this one. We'll go ahead and talk through this one together on the board as well. So the question asks, is a minus b less than 7? Statement 1 tells me that b is less than negative 13. So this is where I'm going to start to get into, and one of the things that we're going to get into in much even greater detail towards the end of this video is kind of the logic versus algebra, when to use logic, when to use algebra sort of thing. But just with statement 1, when I look at it. So the question is whether a minus b is less than 7. And what I know is this, is I know that b is less than negative 13. But to be honest, that doesn't give me first of all, that doesn't give me any information on a. Secondly, because a could be really anything from all the way up to infinity, all the way down to negative infinity, right? In theory, a minus b could still be anywhere, right? Another way that I could frame the question, if I wanted to think about the question in another way, was I could rewrite it. I could add b to the other side and then subtract a, and I could ask myself, I could reframe the question as, is b greater than a minus 7, right? And again, that's my question. I got to keep that in mind. But again, I have no information on a, so I have no idea if b is greater than a minus 7, right? So I can eliminate a and b. Similar logic applies when I get to statement 2, right? I have no information about b, and I'm just not going to be able to get to the place where I can solve this one. So similar logic, and I'll be able to eliminate b. Now, when I think about these two statements together, this is where there's a lot of helpful takeaways on this one, just on how to deal with absolute value. With inequalities. A lot of good takeaways on how to deal with inequalities that are going to apply on some later questions. So some good things to keep in mind. One thing is that we can add inequalities, but we can't subtract inequalities. So I'm going to take the information from the two statements, and I'm going to try and combine it. And statement 1 tells me that b is less than negative 13. And then I'm going to rewrite this with my sign pointing the same way so that I can add the inequalities. I can't add inequalities if the signs don't point the same way. So I'm going to rewrite this with the sign pointing the same way. And I'm going to say that negative a is less than 5. From here, what I can do is I can start to I can add these two inequalities together. Again, I can add inequalities, I can't subtract them. So I'm just going to add these two inequalities. What I get then is b minus a is less than, and negative 13 plus 5 is going to be negative 7. Now, I can tell that this is starting to look a lot like this. So what I'm going to do here is I'm going to rearrange this. And there's a couple options. Number one, what I could do is I could pull out a negative here. And I could say that this is really negative a minus b. And I could say that that is less than negative 7. From here, what I could do is I could divide the whole thing by negative 1. But important to remember that when dividing by negative 1, with inequalities, I've got to flip the sign. When divided by a negative at all with inequalities, I've got to flip the sign. So what that would mean is that a minus b is greater than 7. The other way that I could think about it, the other way that I could do it is that I could say, okay, let me add 7 to both sides. So now all of a sudden 7 is over here. Let me subtract b from both sides. So I'm going to have a negative b on my right-hand side. And let me add a to both sides. And again, I get to the same place. A minus b is greater than 7 here. A minus b is greater than 7. Again, the answer to our question, is a minus b less than 7, is no. But I do have an answer to the question, and so that's sufficient. And so C is going to be the correct answer to us here. But several good takeaways as it relates to inequalities here. You can't, when you divide by a negative, you've got to flip the sign. You can add inequalities as long as the signs are pointing the same way. You can't subtract inequalities. Good things to keep in mind as we get into some more advanced questions later in the video. Let's go ahead and take a look at this next one together. Awesome. Hopefully you've had a second to work through this one. We'll go ahead and talk through this one together on the board. The question asks whether the absolute value of x plus 2 is less than 6. And this is another one where there's a couple different routes I could take on this question. And one of them is I could use some algebra, and I could kind of split this thing up into a couple separate inequalities, and I could work through it that way. That is, if you're super comfortable with that, that's okay. But I want to challenge you in this video to think about this in a little bit of a different way. If you're unfamiliar with thinking about absolute value in terms of distance, we covered that at the end of the algebra video, the last couple questions of the algebra video. So take a second. If this sounds completely unfamiliar to you, you're completely lost. That video we covered in a little bit more detail that I'm going to in just a moment, thinking about absolute value in terms of distance. But again, on this particular question, the question asks, is the absolute value of x plus 2 less than 6? And immediately where my mind's going to go on this one is I'm going to think about this in terms of distance on a number line, okay? And if you remember, the way that I'm going to think about the absolute value of x plus 2 is I'm going to think about it as the absolute value of x minus negative 2, which is then going to tell me the distance between x and negative 2. And so my question becomes, is the distance between x and negative 2, is that less than 6? So I'm going to put negative 2 here on my number line, and what 2 points then, I ask myself, are 6 away from negative 2? Well, 6 greater than negative 2 is going to be 4. 6 less than negative 2 is going to be negative 8. And so essentially, my question is the distance between x and negative 2 less than 6? So does x fall in this range? And so this becomes my question. Or I could rewrite it as, does x fall, is x greater than negative 8 and less than 4? And again, I'm going to put a little question mark here, a little Q here, just to remind myself that that's my question. That's not actually information that I'm given. Statement 1 tells me this, that x squared is greater than 9. Now, there's a couple different ways I can think about this, but I could say, well, I can take the square root of both sides, say that the absolute value of x is greater than 9, which means, is not greater than 9. The absolute value of x is greater than 3, which would then tell me that either x is greater than 3 or x is less than negative 3, or you could just think through here what would have to be true of x for x squared to be greater than 9. Okay, x would have to be less than negative 3. X would have to be greater than 3. Well, what that tells me here is that x either falls to the left of negative 3, or x falls to the right of 3. Now, the problem here, of course, is that there's still some space between 3 and 4, so x could fall in the range that I'm looking for, or x could fall on the outside. Same thing on the left-hand side. I can say x could fall in the range that I'm looking for. It could be greater than 8, but it also could fall on the outside. So statement 1 is not sufficient. I can eliminate A and D. When I look at statement 2, this is interesting here. So it tells me that the absolute value of x minus 3 is greater than 11. Okay, remember, we're thinking about absolute value in terms of distance. And so the absolute value of x minus 3 is going to tell me the distance of x from 3. I'm going to clean this up real quickly for just a moment. And so what it tells me is that the distance between x and 3 is greater than 11. So again, I've got my critical point 3 here, and I'm going to think about what 2 points are 11 away from 3. Well, 11 to the right on the number line of 3 is going to be 14. So I know, again, the distance between x and 3 is greater than 11, so x is going to fall on this side of 14. Or x could fall on this side of 3, but again, it has to be 11 away. So 11 away from 3 to the left-hand side is going to be negative 8, right? It's going to be 3 minus 11, which is going to be negative 8, which is right here. And what it tells me, again, is that the distance of x from 3 has to be greater than 11. So, okay, x has to be on this side of -8. Now this actually, it tells me that x doesn't fall in this range between -8 and 4, right? And so because it tells me x doesn't fall in this range, that is an answer to the question. The answer to the question is no. And so statement 2 here alone is sufficient, and the correct answer is going to be B. Again, just a helpful way to think about absolute value, to think about absolute value in terms of distance. That's going to come up later in this video, so you're going to want to keep that in mind as we get into some of these harder questions. Just a fair heads up for you here that this next question we're going to do is challenging, but after this next question, it's going to get really hard in this video, as promised at the beginning in the intro. So we'll go ahead and we'll take a look at this next question together here. I'll put it up on the screen and take a second to work through it. Awesome. Hopefully you've had a second to work through this one. If you haven't had a second to work through this one or still working on it, you can go ahead and pause the video at this point. We'll go ahead and dive into the answer explanation for this one. The question asks if a and b are integers and ax is greater than -bx, is x greater than 0? Before I even get to the statements here, I'm going to want to push this question and kind of push the information that I'm given. So the information in the question, again, ax is greater than -bx. So I'm going to push that, and I'm going to use some of the skills we've discussed in the previous question. And the way that I'm going to look at this one is this: remember, I can't necessarily divide by x because I don't know whether x is positive or negative, so I don't know whether or not to flip the sign. But what I can do is this: I can say that ax, and then I'm going to add bx to both sides. Ax plus bx is greater than 0. Now, again, I'm not going to write that this is the question here, even though this information was given to me as part of the question. And the reason for that is that I've been given this information and I know that this is true, right? The question is x greater than 0? This is information that I've been given that I know is true. From here, what I'm going to do is I'm going to factor out an x. I'm going to say x times a plus b is greater than 0. Okay. And so again, I know that for sure. That's not a part of the question, but that's helpful for me because another way that I can look at this question now is that, well, so if x is greater than 0, if I have a positive here, then a plus b is also going to have to be greater than 0. Or if x is negative, then a plus b is going to have to be negative. And the reason for that is because I need positive times positive to be greater than 0. I need negative times negative to be greater than 0. Okay, so the reason that's helpful is when I get to, all of a sudden, I kind of have two paths to the solution, right? If I can figure out the sign of x, that's helpful. If I can figure out the sign of a plus b, that's also helpful. So with statement 1 here, statement 1 tells me that a plus b is greater than 0. Well, if a plus b is greater than 0, then this whole thing right here is positive. And if this whole thing right here is positive, then I know that, again, x also has to be positive. So if a plus b is greater than 0, then I know that x is also greater than 0. That is sufficient to answer the question that I'm asked. So I can go ahead and I can say, I can say that B, C, and E are out. It's either going to be A or D. When I look at statement 2 here, statement 2 tells me this, that A is greater than the absolute value of B. So for statement 1, I used a little bit of algebra. Here I'm going to use a little bit of logic. And when I think about this, kind of the way that I'm going to process it is this, is that I could say, well, a couple things that I know. Number one, I know that A is positive, right? Because if A is greater than the absolute value of B, the absolute value of B is going to be positive. And so I know for sure that A is positive. I also know that if A is greater than the absolute value of B, that also tells me that the absolute value of A is greater than the absolute value of B. But the reason that's important is this, is that if A is greater than the absolute value of B, whether B is positive or negative, when I add B to A, even if B is negative, the absolute value of A, so A is further to the right of 0 than B is to the left of 0. So when I add them together, I'm still going to end up on the right side of 0. Okay, another way I could think about this, is I could say, okay, so A is greater than plus or minus B, right? Now, obviously A is going to be greater than the negative version of B. A is going to be greater than the positive version of B as well. But basically what I know is because A is further to the right of 0 than even if B is to the left of 0, I know that when I add those two together, I'm going to get something positive. Because I know, again, that A plus B is going to be greater than 0. I also know that X is going to be greater than 0, and that's going to be sufficient. Now, so hopefully that makes sense to you. Hopefully you're in, and so obviously the answer is going to be D here. But again, some good takeaways there. Pull everything to one side and factor is what I'm going to want to do. I'm also going to want to be able to toggle back and forth between algebra and logic. And we'll get into that a little bit more as we get into some of these harder questions here. Let's go ahead and take a look at the next one together, and we'll talk through it. Awesome. Hopefully you've had a chance to work through this one. The question asks if n is an integer, is m an integer? Statement 1 tells me that m root 3 over root 12 is an integer, and statement 2 tells me that 3m is equal to n cubed minus n. So when I look at this one, there's not a whole lot I can do from the outset to push the question. But with statement 1 here, what I'm going to do is I'm going to write that as m root 3 over root 12, but I'm going to rewrite root 12 as the square root of 4 times 3. And I know that that is, according to statement 1, equal to an integer. I'm just going to go ahead and call that integer a. From here, I can rewrite this and say that m root 3 over, and then I'm going to take the square root of 4. I'm going to make what I've got on the bottom here 2 root 3 is equal to integer a. And obviously my root 3's are going to cancel. I'm going to multiply both sides of my equation by 2. And what I'm going to get is that m is equal to 2 times integer a. Well, if I take any integer and I multiply that integer by 2, then I'm going to get another integer. And so from here, I feel comfortable saying that yes, m is an integer. So statement 1 is sufficient. I'm going to cross out B, C, and E. With statement 2, I'm told that 3m is equal to n cubed minus n. What I'm going to do here is this, is one approach would be to guess numbers, test cases here, and see if it works, right? But that's never a great approach because you never know, have I tested the right numbers? Have I tested the right cases? Have I done it enough? Did I do big enough numbers? Did I do small enough numbers? Did I do? And so it gets very confusing very quickly. What I'm going to do here instead is I'm going to use a little bit of algebra to simplify this for me. So I'm going to say that 3m is equal to, and I'm going to factor out an n, and I'm going to say n times n squared minus 1. From here, I'm going to say that 3m is equal to, and n squared minus 1, that's a difference of 2 squares. And so I'm going to write that as n plus 1 times n minus 1. Then what I can do is say this, that m, I'm going to divide everything by 3, and I'm going to write it in a little bit of a different order. I'm going to say m is equal to n minus 1 times n plus 1 divided by 3. Now, when I think about that, I know that basically on the top of my fraction here in the numerator, what I have are 3 different integers that I'm multiplying by each other, right? Because I know that n is an integer, the question told me that. Okay, so because I know that n is an integer, and I've got essentially 3 different integers that I'm multiplying by each other, the other important thing to notice is that these are 3 consecutive integers. So these 3 consecutive integers that I'm going to multiply by one another, every set of 3 integers has to have a multiple of 3 in it. Why? Because by definition, a multiple of 3 is every third number, right? So 1, 2, 3 is a multiple of 3. 4, 5, 6 is a multiple of 3, right? Every third number is a multiple of 3. And so because every third number is a multiple of 3, when I'm definitely going to have a multiple of 3 in my numerator. In fact, even if you were to say, well, what if n is 0? And then I had 0, negative 1, and 1. Well, even if n was 0 and you did 0 divided by 3 and m is equal to 0, okay, m would still be an integer because 0 is an integer. So what I have here, what I know is this, is that I'm going to have some sort of 3 in my numerator that's going to be able to cancel with the 3 in the denominator, and then I'm going to be left with an integer times an integer times an integer. And an integer times an integer times an integer will always be equal to an integer, and so I'm able to say with confidence that m is going to be an integer and that d is the right answer here. So some important points here, and especially with statement 2, where first thing I've got to do is use a little bit of algebra to make things a little bit simpler. Second thing I've got to do is I've got to use some logic. Oftentimes you will find this to be the case on the GMAT. A lot of students ask, well, when do I use logic? When do I use algebra? Well, one of the ways I like to think about it is this, is you got to remember that the GMAT, it is a quantitative reasoning test, right? It's not a math test, which means that logic is your friend, and algebra is your friend insofar as it gets you to a place where you can use some logic. So you can see what we did here is, this is a very common thing, not always how it works, but a very common thing on the GMAT, where once you do some algebra, you're able to turn on the logical side of your brain and use logic. And one of the skills to develop is that, well, when you're using the algebra side of your brain, you don't completely shut off the logic side of your brain. And when you're using the logic side of your brain, you don't completely shut off the algebra side of your brain. Let's go ahead and let's take a look at another one. And again, just a fair warning for you that we're getting into some questions that are really challenging. And again, as I said earlier in the video, if you're shooting for a 45 to 48 on quant, a lot of these questions are very challenging. And honestly, even if you get obliterated by these questions, it doesn't necessarily mean that you can't score in that range, because it's still possible to score in that range. These questions are just very challenging, and intentionally so towards the end of this video. Let's go ahead and let's take a look at this next one together. Okay, hopefully you've had a second to work through this one. Let's go ahead and talk about it together on the board. So the question asks, is y greater than x? Statement 1 tells me that x cubed is greater than x squared. Now, pretty quickly there, I should be able to realize, okay, x cubed greater than x squared. Well, I have zero information about y. So I can pretty quickly eliminate A and D. Now, I'm going to tuck away in the back of my mind, though, that I think there's probably a lot more information that I could get out of statement 1 than what I just did there, but it's pretty clearly not sufficient to answer the question. So when I think about then statement 2 tells me that y to the x is less than 1. Now that's interesting for me. And what I'm going to do here is I'm just going to use a little bit of some logic. Okay. Because if I think about this, I'm going to think about what x could be, and if x is something, what y could be. So, okay, so if x is, let's say, if x is positive, let's say if x is greater than 0, right? Then what that means is that I'm going to be either squaring y or taking the square root of y, right? If x is greater than 0, then, okay, so what has to be the case? Well, if x is greater than 0, then it has to be the case that y is some sort of fraction. Okay, and here's why, because even if y is some sort of, let's say that y is some sort of negative number, right? Then, well, if y is some sort of negative number and x is, 2, then when I square it, I'm going to get a number that's even greater than 1, right? If y is some sort of number that's greater than 1, whether I square it or take the square root of it doesn't really matter. Whether I square it or take the square root of a number that's greater than 1, I'm going to get something that's greater than 1, right? Because I can never take a bunch of fractions, multiply them by each other, and get something that's greater than 1, right? So, and again, I need y to the x to be less than 1. So if x is going to be greater than 0, then I want y to be some sort of fraction. Okay. Now, right away there, it's pretty clear to me that I don't know whether y is necessarily greater than x. And the reason for that is because, well, if y is a fraction, does x necessarily have to be a fraction that's larger than y or a fraction that's smaller than y? It doesn't really matter, right? So they could be fractions and their relative value to each other isn't exactly fixed here. But I know that if x is greater than 0, then y has to be some sort of fraction. I know that with confidence. I can also say that if x is less than 0, what I'm going to have is some sort of essentially I'm going to end up with 1 over y to the something, right? I'm going to end up with some sort of fraction. So as long as x is less than 0, I'm really not limited on my possible values of y, right? All that I want to be the case is that I want y to be some sort of integer. So with that in mind, I'm going to take this and I'm going to take the information that I have. I'm going to take a look back at statement 1 and see what statement 1 can tell me. Because again, I get multiple possible values out of statement 2. And there is no information that I can necessarily draw about whether y is greater than x. With statement 1 here, there's a couple different ways I could think about this. I could think about this just logically, or I could think about this algebraically. I'll go ahead and show you both here real quickly. Logically speaking, right, I know that x can't be negative because then I would have a negative on this side and a positive on this side, right? That's not going to work. X can't be equal to 0. I also know that x can't be a fraction, right? The reason I know that x can't be a fraction is because when you multiply fraction by fraction, the fraction gets smaller. And so multiplying a fraction by itself 3 times is going to give you a smaller number than multiplying a fraction by itself twice. So think about it logically, I can say that x is going to have to be greater than 1. But when I think about it algebraically, I can do the same thing. Right, I can subtract x squared from both sides. I can say that x cubed minus x squared is greater than 0. I can say then that x squared times x minus 1 is greater than 0. I know that x squared is going to be positive, so then my x minus 1 has to be positive. If I say x minus 1 has to be greater than 0, then x has to be greater than 1, right? So algebraically, logically, get to the same place, x is greater than 1. Okay. When I think about that then here with statement 2, I know that I'm raising y to some power that's greater than 1. Okay. And I want y to the x to end up being less than 1. Well, here's what I know, is that if x is greater than 1, okay, then I know that y could either be some sort of fraction, or y could also be, if I end up having an odd integer, y could also be some sort of negative. Right, because negative 3 raised to the third, right, is going to give me negative 27, which is less than 1, right? So if x is greater than 1, y could also be negative. Doesn't mean y has to be negative. Doesn't mean y, if x is 2, it can't be a negative. But y could be one of 2 things. It could either be a fraction or it could be a negative. But what I notice is this, is that there is no possible situation that y is also greater than 1. Because if y is greater than 1 and I raise it to another power greater than 1, then that is just going to increase y. And I can't increase y because I want y to the x to be less than 1. So with that combination of algebra and some logic here, I'm able to deduce that y is either a fraction or a negative. X is greater than 1. Well, if y is a fraction or a negative and x is greater than 1, then all of a sudden, and again, I eliminated statement 2 just a moment ago, but then all of a sudden what I know is that there's no possibility that y is greater than x, right? Because x is greater than 1 and y is a fraction of negative. Y has to be less than 1. So for that reason, both statements together is sufficient. The answer here is C, but you can see this is a great question. This is a great example of, where I have to use a combination of logic and algebra, right? I had to, even as I was thinking through statement 2 here, I had to think through some different possibilities for what x could be and what y could be, right? I had to use some logic and I had to use some algebra. If I started picking numbers here, then I'd have to make sure that I test the right cases or guess the right numbers. And I'm never going to know, have I guessed the right ones? Have I tested the right ones? How do I know? Right. But if I'm able to use logic and I'm able to use algebra, then I'll be able to think through these things and hopefully arrive at a solution logically. Hopefully that was helpful for you. I want to go ahead and I want to take a look at another one together here where, again, it's going to be helpful to use some logic as you're going through this, but I'll go ahead and put this up on the screen, give you a moment to work through it. Awesome. Hopefully you've had a second to work through this one. The question asks this: if the absolute value of x is not equal to the absolute value of y, which is not equal to 0, is x squared over x squared minus y squared greater than y squared minus x squared over y squared? And obviously when you read that question by itself, it's already pretty intimidating. It doesn't look like the question is going to be a whole lot of fun. But one thing that I'm going to notice here that is going to be super important, right? And there's all sorts of things that come to mind when I see this question, right? I see the difference of squares, right? I see a y squared in the denominator, and I know y squared is going to be positive. So I think, okay, I could multiply both sides by y squared. Will that get me somewhere, right? There's a lot of things that come to mind initially. But one thing that I want to jump out to you here is this. And this is a good takeaway for many questions that you'll see on the GMAT. And that's this: anytime you have some version of x minus y on one side and y minus x on the other side of some inequality or equation, or anytime you have something like that on the GMAT, I want to jump out to you that unless y and x are equal to each other, one side is going to have a positive and the other side is going to have a negative, or it's going to have a negative. That you're going to get opposite signs on each side, that each side's going to have an opposite sign. Because the reason that that's particularly relevant is it actually helps me push the question a lot here, right? So anytime you see some version of this, you're going to want it to jump out. In this particular question, right, it happens to be x squared minus y squared and y squared minus x squared. And so hopefully what pops out to you here is this, is that on my left-hand side of my question again, I'm going to have some positive, because I know x squared is going to be positive, over either a positive or a negative. And my question is whether that's going to be greater than some, again, positive or negative, over a positive. And what I realized really quickly here is that this x squared minus y squared thing is going to be very important. Because if x squared happens to be greater than y squared, well, then this is positive and this is negative, and the answer to the question is yes. If y squared is greater than x squared, well, then this is positive, this is negative, and the answer to the question is going to be no, because I'm going to have a negative on this side and a positive on this side. And so really quickly, as I start to push the question here, and again, this is a really challenging question. I'll say it again, if you're shooting for 45 to 48 on quant, you don't necessarily need to get this challenging of a question, right? But there are some good takeaways here, right? So when I start to push the question, really what the question becomes for me is x squared greater than y squared? Because if x squared is greater than y squared, then the answer to my question here is yes. If x squared is not greater than y squared, and of course I also know they're not equal, by the way, but if x squared is not greater than y squared, then the answer to the question is no. So if I can just get to here, then I'll have an answer to my question. And again, you can see on this particular question why pushing the question on the GMAT is so important. Because if I take this and I try and bring this whole thing and answer this whole thing with either of these two statements, things get very confusing very quickly. Picking numbers can be an absolute disaster on a question like this. Testing cases, same thing, right? Especially if I start getting into fractions and I'm squaring fractions and I'm subtracting fractions and I'm squaring, and right, things get very confusing very quickly if I try and go that route. But if I use a little bit of logic here and I'm able to boil my question down to, okay, is x squared greater than y squared? Well, all of a sudden things become a lot more simple. So statement one tells me this, that the absolute value of x minus y is greater than 1. Now, just worth noting, right, we talked about using logic, think about things in terms of a number line a little bit earlier in this video. I could say, really what this is telling me is that the distance between x and y is greater than 1, right? But just because the distance between x and y on a number line is greater than 1 doesn't necessarily, it could be, right, and not that I would necessarily want you to go down this route, right, because you get kind of close to testing cases here, right? But you could have, x here and y here, in which case y squared is going to be greater, or you could have the reverse, right? X here and y, in which case x squared is going to be greater, right? So I'm not going to get an answer to my question here, my pushed question here. And so this isn't going to provide me sufficient information to answer the question. And so with that in mind, I can eliminate A and D. When I think about statement 2 here, I'm told that the absolute value of x is less than the absolute value of y. Well, here's what I can do. I can actually square both sides here. And the reason I can square both sides here is because I'm dealing with absolute value, I know that I'm not multiplying by any sort of negative, right? So I can square both sides and I don't have to flip the sign. I don't have to worry about it because I know I'm dealing with positives, right, on both sides. So what I'm going to get is I'm going to get that x squared is less than y squared. Of course, when I look at that, I say x squared is less than y squared. All of a sudden, I have an answer to my question, right? The answer to my question is no, but that's still an answer to my question, right? And so, so statement 2 alone is going to be sufficient. Again, just to push this a little bit further, just to, again, take it back to the question, just so you can fully understand it, right? I could rewrite this as x squared minus y squared is less than 0. Well, all of a sudden, what that means is this, is that in my question, I'm going to have a positive over a negative on my left-hand side. And on my right-hand side, again, I could rewrite this another way, and I could say that y squared minus x squared is greater than 0. On the right-hand side, I'm going to have a positive over a positive, right? So I'm going to have a positive on my right-hand side, a negative on my left-hand side. Again, I can say that my positive is definitely going to be greater than my negative, so I have an answer to my question here. So again, this is one where you can push the question, right? Pushing the question makes your life a lot easier. And the way that you push the question is using a little bit of logic. Anytime I see that x minus y on one side, y minus x on the other side, some alarm bells are going off in my head, right? May not always be helpful, but some alarm bells go off in my head. Hey, I want to take note of that. And I want to think about that and how it may have an impact on the question or the answer choices. With that in mind, let's go ahead and let's take a look at another one here. And we'll talk through this one together. I'll give you a second to work through it. And then afterwards, we'll talk through it together on the board. Okay, hopefully you've had a second to work through this one. The question asks, if A is equal to the absolute value of B minus 6 plus the absolute value of B plus 2, what is the value of A? So when I see this question, there are a couple things that come to mind. Number one, in theory, I could think about doing this algebraically. But the problem is that if I think about it like that, then I've got, so A is equal to plus or minus B minus 6 plus or minus B plus 2. And all of a sudden, I'm really confused because I don't know whether I can solve that, and I don't know. It feels like there's going to be at least 4 different equations I'm going to have to break out, and I'm still not sure that that's going to get me anywhere. So I can see pretty quickly that the algebraic route isn't going to be a ton of help to me. So I'm going to have to look for another route, but there's not much I feel like I can do here to push the question. And so I'm going to go ahead and I'm going to take a look at these statements. Statement 1 tells me that A is an integer greater than 7, right? And so now my mind's going to go to, okay, possible values of A if A is an integer greater than 7. That doesn't seem off the bat to help me, right? I have a couple options though. I could start to test cases, but if I test the wrong cases here, and we'll get into why this is in just a second, but I'm going to repeatedly get the same integer, and I may be led to think that statement 1 alone is sufficient. What I actually am just going to go ahead and notice here is this. If A is an integer greater than 7, right, I could have plenty of possible values of B, right, all the way up to infinity. And the value of A is just going to continue to increase and continue to be an integer that's greater than 7, right? Because the more I increase B, the more that I'm going to increase A here. So that's what I get from, the higher that I take B, the higher I'm going to take A here. So that's what I get from statement one. So statement one's not going to be sufficient for me. Statement two tells me that B is between -2 and 6. And now this is where things get interesting for me, because I'm going to look back at the question and I'm going to reinterpret the question logically here for a second. And I'm going to think about it in terms of a number line, as we've thought about some of these absolute value questions in the past here. So if I draw for myself a number line, A is essentially equal to the distance of B from 6 plus the distance of B from -2, right? So I've got the point -2 on here, and I've got the point 6 on here. And A is equal to the distance of B from 6 plus the distance of B from -2, right? So in theory, if B is all the way up here at infinity, right, I've got the distance of B from -2 plus the distance of B from 6, right? Same thing down here. But what's interesting is what happens when B falls inside this range, right? Because if B falls here, then no matter what B is, B could be 0, B could be 4, B could be -1, right? No matter what B is here, these two distances, the distance here and the distance here, these two, when I add them together, are going to be equal to -2, right? The distance between -2 and 6, right? Because anytime B falls in this range, these two distances are going to add up. They're going to make up the entirety of the distance from 6 to -2. And so what happens is that statement 2 tells me that B falls in this range. So no matter where B falls, B could fall right here really close to 6, and the distance is going to be 8, right? Because the distance between -2 and 6 is 8. Or B could be really close to -2, the distance is going to be 8. B could be in the middle here. The distance, these two pieces are still going to add up. No matter where I put B, my two pieces are still going to add up to be 8 as long as B falls in this range of -2 to 6. And so statement 2 alone is actually going to be sufficient here, and B is going to be the correct answer. And again, this is one where if I look at it logically, again, hard question, so don't freak out if you felt very challenged by this question, because again, if you're shooting for the 45 to 48 range and even potentially beyond that, this is a really hard question and not one that you necessarily need to get right. But there are some valuable skills here. And if I think about this logically, this question becomes much easier than it would have been otherwise. I want to go ahead and we'll take a look at one final question together. And again, this is another one that's pretty challenging, but I'll give you a moment to work through it. After you've had a second to work through it, we'll come back and we'll talk about this one together on the board. Awesome. Hopefully you've had a second to work through this one. The question asks, if the absolute value of x is not equal to 1, is x over x plus 1 greater than negative x over 1 minus x? And when you see this question, if you're like me, it looks pretty challenging from the get-go. And kind of the first question that I ask myself when I see it is this, is what should I do first, right? What can I do first? Well, there's no obvious way to me to push the question, but I do want to see if I can simplify the question and make things a little bit easier for me to see, because right now I really can't see a whole lot when I look at it. So what I'm going to do here is this, is I'm going to, ask myself, what can I do, right? Which is a lot of times, a lot of people say, well, how do you know when to do this? Or how do you know when to do that? And oftentimes a lot of it's feel, but a lot of it is asking yourself, okay, what can I do, right? What am I able to do that may make this question look a little bit easier for me? So with this one, for example, I know that I can't cross multiply. My first instinct would be to cross multiply, but I can't cross multiply because I don't know, is 1 minus x or is x plus 1, or is one of those going to be negative? Am I going to have to flip the signs? I just don't know, because I don't know whether it's going to end up working out, whether I'm going to have to flip the sign. I can't do that. So what I'm going to do instead is I'm going to try and rewrite the question in another way that hopefully will help me see things a little bit better. I'm going to rewrite my question and say, is x over x plus 1 greater than, and what I'm going to do on the right side of my inequality here is this, is I'm going to take the negative out of the numerator and I'm going to insert it into the denominator. And so instead of having negative x over 1 minus x, I'm going to multiply that denominator by negative 1. And again, I'm just moving it from the numerator to the denominator. And so I'm going to have x minus 1 on the bottom of my fraction. So x over x minus 1. Now you may say, how did you know to do that? Well, I don't really know to do it. I don't know that it's necessarily going to work out for me. I just know it's, it feels like to me it's the one thing that I can do here, right? So can it maybe make things a little bit easier for me? I know it's going to make my numerators the same, and so maybe it'll be easier to compare denominators, right? But when I see that, okay, that's one thing that I know that I can do, right? Now I start to look at statement 1. And what statement 1 tells me is this, is that it says that x is greater than 1. Well, if I know that x is greater than 1, that actually starts to become pretty helpful for me. I know my numerators are going to be the same, right? And so when I have two fractions with the same numerator, right, the greater of the two fractions is the one with the smaller denominator, right? Smaller number in the denominator means a greater overall number, right? So because they have the same numerator, all of a sudden my question becomes, which of these has the smaller denominator? Now, the other thing I need to keep in the back of my mind is, does one of these have a negative denominator? Because if one of them has a negative denominator, then, okay, all of a sudden that's going to present a different challenge, because it could have a smaller absolute value in the denominator, but it's going to be negative, then that could create issues for me. But what happens is this, is I know they're both going to have positive denominators, right? I know everything's going to be positive here. So my question becomes, which of these two fractions has a smaller denominator? Because the one with the smaller denominator is going to be the greater overall fraction. And when I think about it that way, it's pretty easy for me. Obviously, x minus 1 is going to be a smaller denominator than x plus 1. And because they're both going to be positive, I know that the right-hand side of my inequality is going to be greater than the left-hand side of my inequality. And all of a sudden, that becomes very helpful. That answers my question. And again, you can see there that all I used was logic. Could I do it algebraically? Sure, I could do it algebraically. But using logic there was much quicker than using algebra. And it also, made sense, and I was able to think through it. So with that in mind, I know statement 1 is sufficient, so I can cross out B, C, and E. When I get to statement 2 tells me that x over x plus 1 is less than 1. But again, that feels like to me, that doesn't tell me a whole lot, right? It tells me that this left-hand side of my inequality is less than 1, but it doesn't give me any information about this right-hand side of my inequality. I start to think to myself, okay, could I multiply both sides by x plus 1? But again, if x is negative, I'd have to flip the sign, so I don't know that I could necessarily flip the sign. And so all of a sudden, statement 2 doesn't actually give me a whole lot of information, right? For that to be true, x could be just about any positive number, well, really any positive number, and with any positive number, x over x plus 1 is going to be less than 1. And again, just because I know that I have some positive number doesn't necessarily tell me, right, whether or not x over x plus 1 is going to be greater, right? We saw here that if x is greater than 1, then the right-hand side is going to be greater than the left-hand side. It actually happens to be the case that even if x is positive and x is less than 1, if x is between 0 and 1, then what's going to happen is I'm going to have a negative on this side. So my right-hand side is going to be less and my left-hand side is going to be greater. So you can see there how logic, and the answer here is going to be A, right? But you can see there how logic, when I use logic rather than testing cases or guessing numbers. So often we see students that come to us and they test cases, they guess numbers. And what ends up happening is they talk themselves in circles because it's so hard to keep track of all of that. And you never know whether you're supposed to, which cases you're supposed to test, and have I tested enough cases, and have I tested the right cases, have I guessed the right numbers, right? And so the problem is, or the challenge is using logic and remembering that this is a quantitative reasoning exam, and that's what we're going after. So hopefully this has been helpful for you. I want you to remember some of the key takeaways of this video, some of the key things that we talked about throughout. Obviously, probably the biggest theme as we went throughout here was don't test cases. Don't pick numbers, right? That's never actually helpful. That never actually gets you where you want to be. You're also going to want to use logic and algebra, right? When you can't think through things logically, okay, can you use some algebra to get you to a place where you can think through things logically? And then you're going to want to remember to push the question, because you saw that come up repeatedly as we went throughout here. Hopefully this video has been helpful for you. If it has, be sure to check out some of our other videos, and we will see you next time.